So today we're basically joined by Michael, who I believe is a professional engineer from Princeton. Correct me if I'm wrong.
That's right. Yeah, that's where I got my undergraduate degree.
Awesome, awesome. So what the plan or aim of the start of the session is for you, Michael, just to be able to kind of express like, your backgrounds, your career progression, and so on, as your life as a career or professional engineer to some of the students who have learned a bit about what it means to be an engineer yesterday, but it'll be really valuable to hear your experience on kind of how you found it and what you're currently working on and what your kind of day-to-day life is like. So I'm going to pass over the floor to you, and you'll have, I think, up to around 30 minutes in total, but then there'll be some opportunity for questions towards the end as well. Yeah, so can you just tell us more about your kind of occupation and what you do?
Yeah, sure. And I also did a few slides just to orient people to maybe what
Oh, awesome.
structural
Let
engineering.
me see if I can allow kind of sharing on your behalf. Let's see.
Sure. Yeah.
Yeah, I think you should be able to share now.
Okay. Um, let's see.
Yep, that's great.
That's still working there. Okay.
Yes, that's good.
Yeah. Okay. Yeah. Um, yeah. So my name is Michael Weinert, and I'm currently a product manager for Simpson Strong-Tie, and I'm the product manager for mass timber and offsite construction. But I wanted to start kind of from the beginning, how I got to this point in my career. And the slide up there is my basic education background. I did my undergraduate degree at Princeton in civil and environmental engineering with a certificate in architecture. So my studies really focused on structures, architecture, but also I did visual arts. And because I was at Princeton, it was just an amazing opportunity to study the liberal arts as well. So I would say my undergraduate degree was very broad. I don't think I knew enough about engineering when I came out to be a really good engineer, but I knew a lot. I had a very well-rounded education, I would say, and that served me well later on in my career. But um, after that, I did work for a little while, about 7 years, and then I went back and got my master's at University of Washington. Um, Studied earthquake engineering, accelerated bridge construction was my research project. And one of the great parts was I got paid to go to school. So I was doing either research or teaching as part of my master's degree. Later on in my career, I also did a certificate in commercial real estate development, as a lot of what you do as a structural engineer relates to what real estate developers are thinking and wanting to do. And I wanted to understand that side of the business a bit more. And then throughout my career, I've just had various schooling in art through independent study in New York City, Washington, D.C., and even some time in Italy. So I wanted to, following on the education piece, this is one of the things that really inspired me. This was a picture of Professor David Billington. He was my advisor at Princeton as an undergraduate. He passed away a few years ago, but he really pioneered this idea of structural art. And that got me really excited about being a structural engineer. Because I was an artist in high school, and I was also good at math, and I wanted to figure out how can I combine these things. And I found his research and lectures really inspirational. And this was one of the seminal books that he wrote, The Tower and the Bridge, The New Art of Structural Engineering. And he introduced a few special engineers, Robert Maillard being one of them. These are a couple beautiful structures that he designed probably in the 1930s out of reinforced concrete. Really elegant structures that that I believe do combine art and engineering. And the second one I wanted to mention was Pier Luigi Nervi, another structural engineer combining art, architecture, and engineering. He was known for some of his large scale domes. So this is a concrete dome in Italy. And this was in a time before computers and all the computational power that we have now. They figured out how to build very slender, efficient structures like this in like 1950. So, and there's another slide of just a floor slab, but how the floor slab is following the flow of forces in the floor in terms of where the material of the floor is placed. So after my undergraduate, this is just a quick summary of what I've worked on. So I've had a pretty varied career. Some people started a company and stay there their whole career, but I've explored around a bit. I did start in traffic engineering and urban design in New York City. Had an opportunity to work on the World Trade Center redevelopment after 9/11. I also tried my hand at architecture for a year, thought I wanted to go to architecture graduate schools, decided not to ultimately. And that's when I started my career in structural engineering full on. And so I've worked on a variety of projects. As a structural engineer, you can work on so many different types. So a couple that I have worked on are single family homes, renovations, historic buildings, high-rise towers, mass timber, which is what I really focus on now, and pedestrian bridges. And I also spent time in manufacturing, which is what I do now. I worked for a company called Katera, which was a startup that was trying to design buildings as products that you can configure and buy off the shelf. But I'm not talking about a backyard shed. We're talking about, large multifamily buildings. The company did go bankrupt, and that was a blessing in a way, and led me to my current position where I still get to focus on offsite construction and mass timber, but I now focus on creating connectors and fasteners that engineers will specify to build their mass timber buildings. And I just want to show a few images of like what structural engineers work on, the types of projects, what they look like, just to give you a flavor. I know some of you might not have been exposed to this. So here's just some single family homes I've worked on. That's kind of the most architect driven space where, the forces are small, the buildings are small. You can do a lot of creative things with the form of the building. And as a structural engineer, you try to help facilitate that. Here's just a smattering of some random projects. Also, this one in the lower middle is probably the tallest car dealership in the US. I don't know if I can perfectly verify that, but it is it's basically a 6-story parking garage for Toyota and Honda in Seattle. And most car dealerships, as you've maybe seen, are all just spread out over the ground. But this one, it's quite tall and quite a big structure. So that was fun to work in my own backyard on. Also, just figuring out facade projects. So this is a complex precast and glass facade. This is another facade project for a church to redo all the facade on this historic church. And this was just a hotel in Nashville, Tennessee for a Hyatt Place. We also can work on artistic things as a structural engineer. On the right is a sculpture by Michael Heisler, which is a gigantic triangular box that's set into the ground. And we had to design the box to deform to make this shape, this evocative rift that's closing in the ground. So it's a piece of land art that I got to work on. And then a couple projects on the left, different university project on the top and a museum project on the bottom. If you've been to Washington, D.C., there's the National Museum of American History. That was actually my first project as a structural engineer that I got to work on, which was really cool. And then, yeah, here's some hanging sculptures and a nice glass and steel roof that I also got to work on for that university project. This is probably the most complex and challenging project in my career. This was a over 40-story residential tower in a high seismic zone in San Francisco that was also connected to a 10-story building by a seismic joint. But it spent probably over 4 years from start to finish on it. You can see a picture during construction, all of the reinforcing steel being placed before they pour the concrete. A picture from the top with the San Francisco Bay Bridge. Solar panels, solar hot water panels that were being placed as a way of saving energy on this building. So really complex building, really fun. I learned a lot and really helped me grow as a project manager. But I also mentioned pedestrian bridges. I've had those, worked on those throughout my career. There's a variety. There's some that are very simple in the upper left. That was a hospital bridge between two parts of a hospital. Upper right, there's a pedestrian bridge, more playful, but it actually was built. Lower right is a really fanciful submission for a competition. Never got built, but it was really fun to work on dreaming up what kind of pedestrian bridge you could hang off this existing vehicular bridge. And the lower left is just some of the drawings that might be produced for a bridge. And that's a big part of what you do as a structural engineer, creating the drawings for how these things will go together and what the components it's made of are. More and more that's going into 3D realm, but still 2D drawings are used pretty heavily. And then I just want to show a couple slides of what I mean by mass timber. Slide on the right is a really good one to show. These are large engineered wood elements. So you're gluing together small pieces of wood to create big pieces of wood that you then fabricate in a factory and ship to a site and assemble kind of like Legos. This is the new hot construction idea in the US, partly for carbon emissions issues because wood sequesters carbon as opposed to concrete and steel, which are takes a lot of carbon emissions when you're manufacturing those materials. So there's a lot of interest from that reason. Also just people like to be in these natural wood spaces. So this is becoming more and more popular, and also labor shortages. So it takes fewer people on site to just snap these Legos together. So I got really interested in this, and that's where I've decided to specialize in my career right now. So that's the end of the slideshow. So hopefully that gives a little orientation to what one person's career in structural engineering can work on, and a little bit about my educational background. So I wanted to start with that, and then I don't know, Akash, if you wanted to focus the discussion anywhere else after that.
Yeah, no, thank you for sharing kind of some of the projects that you've worked on and your educational background. I'm sure it's super interesting to hear for our students and really valuable to get your kind of experiences shared. So I think what we'll try and do is kind of see if the students have any questions at this point. And if not, then I have some questions I've written down that I can ask as well. So do any of you have questions? Feel free to ask them either in chat or go ahead and unmute yourself. So I'll get started then. So Michael, you explained.
I see a hand was raised.
Oh, there's a hand. Who was that? Someone's put it down. Pinaki, yes, go.
How much do you have? What is your average salary?
At what point in your career?
Like towards the beginning of your career, the first 2 years.
Yeah. Well, I'm sure it's changed since I was a new engineer, but I think for structural engineering, and if you have let's say a master's degree, I would guess it's around 75,000 a year, 75,000 US dollars a year. Yeah, I would say that's going to be, probably lower than some other engineering disciplines to start. But yeah, that's what I've seen, probably around there. Now it can just really depend whether you're in a big city, a little city, a big firm, a little firm. Yeah.
Okay, thank you.
We have one in the chat as well.
What degrees do you need?
Yeah.
Okay. Well, architect and engineer are slightly different paths. So if you want to be an architect in the United States, there are accredited architecture degrees, either a B.Arch, Bachelor of Architecture, or a M.Arch, a Master of Architecture. Both of those are professional degrees, and they can be used as the prerequisite for getting your license. To get the license, though, you also do need additional experience and pass certain tests. I haven't done those for the architecture, so I don't know a ton of details about the exact tests, but there's quite maybe 5 or 6 different tests you have to take. As an engineer, you would typically want to have a bachelor's degree, and a master's degree can just help reduce the amount of experience you need before you get your license. So either a bachelor in engineering or a master's in engineering, and then typically you need 4 years of experience to become a professional engineer. And then I also have a license that's called structural engineer. So that's a progression, more specialized than professional engineer. And that takes another 2 years and another test, a couple tests to get that degree or to get that license. So, if you count schooling and experience, it's probably 10 to 11 years before you become a licensed structural engineer.
Thanks, Michael. In the US, did you mention that you have to get a professional or license as a professional engineer first and then one as a structural engineer?
Yes.
Right.
Yeah, actually in California, you can get your professional engineer license in 2 years. There's some states.
Okay, so it depends on the state as well.
Yeah, but they also have different tests. You have to do seismic specific tests there. But yeah, it is seen as a progression. The testing for professional engineer is much more broad. Usually, you're being asked about disciplines that I forgot. There's also an engineer in training test that you take right after school. So before you have any experience, you're really taking that test. That's testing you on physics and chemistry, things that are very, very broad. And when you become an engineer, you're not using a lot of it, but you have to take this test. Then the professional engineer is less broad, but still kind of broad, where you're doing some questions in other disciplines of engineering that you might not practice in. And then, structural engineer. So you need the structural engineer license in certain states to work on buildings over a certain size or bridges over a certain length, because those become more complex, and they want to make sure that there's a minimum level of knowledge for people who are going to be saying these are designed in a sound way.
So that makes sense. Can I ask, in the absence of any other questions from chat, what does your kind of average day look like? And can I ask that for at the start of your career, when you first became like a kind of structural engineer, and now as did you say product or project manager?
Product manager.
Product manager, yeah. So yeah, could you just kind of talk us through kind of what it was like at the start of your career and kind of what it is like now?
Yeah. So at the start, when you're working in a design office as a structural engineer, it's pretty good variety day to day. I worked in a company that did new construction, historic buildings, renovations. So all those are a little different, but I guess at its basic level, you're doing calculations, right? So you're saying, oh, I want to design this beam to span this far and create this size space in this building. What are the loads on it? What materials am I going to use? How does it work with the architecture? And you figure those things out. You have to you make drawings. So you have an analysis with calculations, but then you have to make a drawing that says, well, okay, now that I know what size beam I want or what configuration I want, how do I actually put this together and communicate it to somebody? Like, what does the connection look like between the beam and the column? So then you're doing drawings, either in 2 dimensions, or you could be working on a 3-dimensional model of the building where you're creating the 3-dimensional structure that then will be overlaid with the architecture so that people can check for clashes with, there's also other disciplines, right? There's mechanical, electrical, plumbing, all these other things that have to be in a building to make it function. You have to coordinate them all to make sure, oh, my beam isn't in the way of this duct, or if it is, I need to design a hole in my beam and engineer that. And some of that really detailed coordination does happen downstream, for better or worse. But yeah, so there's calculations, drawings, communication with architects and writing emails, or with builders when things are actually being built. You get to go to the job site and you say, hey, yeah, you're doing this the way I intended, the way that we wanted it to do. Or you say, no, that doesn't go there. And you can definitely catch a lot of things that were maybe not clearly communicated in your drawings. And then that's how you learn how to be better about communicating how to build a structure. But so going on site is very important for the learning process. And most good firms will let you, as a young engineer, be doing that as part of your learning. Then there's also, when you're in construction, you're reviewing the drawings that a contractor makes of what they say they're going to build, and you make sure that matches what you intended before you actually see it on site. So before they fabricate anything, you're checking what should be fabricated. So that's some of what you would do. There's also just, you could even be creating full 3D analysis models of a building or a bridge and checking that the whole structure works for seismic loads or wind loads. So there's kind of a wide variety, and some people end up specializing in one area or another, depending on their skill set and interests. I think those are some of the main areas. And then now it's quite different, I would say. So I guess I'll also mention, your clients, when you're in that setting, are often architects. The architect is the intern hired by a developer, or if you're on a more public or university project, it could be by the university facility staff, or it could be the museum staff, or government, some kind of government agency might be hiring the architect. But that's usually how it flows. There's a contract for the architect, and then they hire all the sub-consultants to help design the structure. I'd say the one place where that's kind of flip is on a bridge. The structural engineer really is the lead. So a public agency would contract with a structural engineer as the lead often, and then they would be they're kind of the prime consultant, and they're subcontracting out to others. But so in that situation, right, you're kind of, the architect is, the owner is setting direction, then the architect sets some direction, and then as a structural engineer, you're trying to help achieve that vision in an economical way, but also, hopefully you can create something beautiful, and then also something that's easy to build. So then as a product manager, yeah, it's very different. Like, and I kind of like this better just for my personality, because I get to kind of drive more what I work on as a product manager. So I'm understanding the needs of our mass timber industry. What kind of solutions do they need for structural connections? And then I work with our R&D engineers to actually physically test these connections in a lab. And then we're able to go back to our customers and say, hey, here's this cool design. It does all these things you want. And we've actually tested it for you. You don't even have to do any engineering calculations. Here's what it's good for, and here's the performance of it. And it becomes really easy for them to just specify it. And then that's kind of how we're adding value, that we're saving them time by doing that. And we're also saving contractors money by being a manufacturing company that can produce these very efficiently. Whereas a lot of structural connections are one-off designs, unique designs that have to be custom engineered, custom fabricated, and that's quite expensive. So anywhere where we can find these commonalities, where we can have the same connection, that's where we're adding a lot of value. So I work with R&D engineers to do that part. I also work with marketing to figure out how we're going to communicate our value to our customers and get the word out about our product line. I work with our sales team to like build relationships with engineers who are going to specify our products, or contractors who might want to tell the specifier, hey, I really like this product, please start specifying it. And manufacturing and sourcing, we're figuring out where should it be manufactured, how are we going to get the raw materials to make it. So it's very much your hands are in a lot of different worlds, and I like that. I've always been kind of more of a generalist. I like the variety of it, but I found a kind of way to specialize as a generalist by being really focused in mass timber. Yeah, so I would say, a couple of things. Like, this was one of the questions I had seen as a possible one, that some advice about things that I maybe wish I had done earlier, or things that can really help you advance in your career in this field. And I think getting field experience and hands-on experience with construction is really important. You can be a great analytical, you can do all the most complex analytical models you want, but if you don't understand how a contractor would actually have to put something together, then you're not going to turn that analytical model into reality. And I think that the more that you have that gut feel for how things go together, or how much things weigh, or how strong a connection is just because you've held it in your hands, I think that really helps. That gut feel really helps you be a better engineer. And then specialization. You can make it in this world as a generalist, but it is a lot easier if you are a specialist. And so if you find a topic or a special niche within structural engineering or architecture, or even if you want to start as a structural engineer and go into construction or contracting, like, to really find a specialty within there makes you really valuable on the team. And so that just makes it easier to have your well-defined important role and get paid well for it. And so yeah, I'd say those two things, that the field experience, hands-on experience, and specialization are something to consider as you're moving through your career.
Thanks, Michael. We have a question from Jaden in the chat. What is the best and worst part of your job?
Let's see. Well, so as a product manager, I think one of the hardest parts is, I don't know if it's a worst part, but a hard part is I don't have my own staff, right? I don't have anyone who directly reports to me. so I have to build kind of consensus and relationships throughout the company to get everybody to say, yeah, like we want to work on this, or yes, I'm going to prioritize this. And so I'm going to really figure out how to navigate all those relationships to get things done quickly and get everybody on the same page. And they might have so they have their own manager who maybe has different interests or different priorities than I do, and they're just trying to navigate that. Can be difficult. And then just for me, I've been at this job for a year, but it's a big company, and just understanding who is the specialist in what within the company and trying to figure out who the right people are to get things done is also kind of difficult. But overall, I mean, I really like the job. I'm really excited to be, at Simpson and doing this product management role. I think one of the best parts is that it is a more self-direct for me, that it's more self-directed. Like I feel like as a product manager, they've described it as kind of being like a mini CEO of a business within a business. So I'm really responsible for the bottom line of like, is our product line doing well? Like, are we being profitable? Are we making the right products? And I like that level of responsibility, and that I can help set that direction and really get to dream up like what's next for our company. So that to me was always a little restricting as a structural engineer working for an architect who's then working for an owner. Is there's not as much freedom in what you're going to work on. So if you're in a niche within that where you really like what you're working on, that's great. But for me, I was always jumping around trying to figure out, well, that's not exactly what I like, or that's not exactly what I want to do. And this was a way for me to focus full time on mass timber, because that is my position. Whereas when you're a consulting engineer, oftentimes it's what did the architect bring in the door as a project, and you just got to figure out how to do that project. So.
Sure. I've had another question from Sam in chat. Would you recommend your career to anyone? I don't know if that's anyone in particular, or just who would you recommend your career to, or your path to? Like, what kind of person?
Well, I mean, I think if you're really passionate about buildings and construction, it is really satisfying, like back on the structural engineering side, to be at the beginning of a project and just see it as some lines on paper or some very rough three-dimensional model, and then to take it all the way through to figure out exactly how you build it, work with the skilled tradespeople to figure out how to build it, and then to really see it come to life and then actually see people using it. That is a really satisfying process, from beginning to end. So I think if that sounds enjoyable to you, to like actually see this thing created out of nothing and become a valuable part. Sometimes you get to work on really iconic things that are shared around the world. So I think, yeah, if you're interested in that, and skill set wise, if you like doing math, physics, especially more on the statics and dynamics. As you get into seismic engineering, you have to understand dynamics of structures. So there's just so many career paths you can have if you start out in structural engineering, because you're not just limited to being a structural engineer, as I've kind of shown through my career path. There's many others of people who then go into real estate development because they understand fundamentally how buildings get built, or they can go into the construction side of things. So you have this structural background, but you then focus on the actual building process. There's a lot of ways you can go if you feel drawn to being around buildings and making buildings and the technology that goes into them. Maybe you're excited about creating more affordable housing. That's a big need that we have nationally and globally. And there's a lot of people trying to figure out how to work on that. And more, we're getting into manufacturing techniques, robotics, new materials. There's a lot of frontiers that I think are exciting for somebody who's just starting out and where their career could take them. So yeah, I think it could be very interesting to a variety of people, but
That's great. Thanks, Michael. I think we've not had any kind of final questions in chat, so I just wanted to ask you kind of in summary, kind of what advice would you give to kind of high school students and any kind of aspiring engineers? Like, what should they kind of focus on? What should they kind of keep in mind as they progress through their education and even in the wider kind of in their wider lives? Like, what kind of particular things should they keep in mind if they are to either follow in your path and become a structural engineer or just more generally as an engineer?
Yeah, I mean, I guess, well, one, I mean, being curious for what's out there and what really just try to look into what the frontiers are, what people are doing. Getting, at a young age, I think trying to find some connection that can get you an internship, just to get a little bit of hands-on experience, so you can, as early as possible, kind of see, like, do I like these kind of people? Do I like this kind of work? Do I like this office setting, or whatever setting it is? Maybe it's in manufacturing, maybe, but just I would say that's something I wish I'd done a little bit more of, is like try out a few different spaces within engineering. So like either, maybe working with a construction firm very early on, maybe end of high school or through college, trying a couple different things to see where my personality and skill sets fit best, or what resonated with me more. So I think, yeah, just keeping that open mind early on, but then, in your studies, certainly, you're going to need to do well in math and physics, but don't forget about the other things like writing. Communication is very important, as most professions, but certainly this one, you're really communicating ideas of how something will go together to a variety of audiences, and so communication is very important. Yeah, I'm sorry. I hope it's a tough question to kind of narrow down, but hopefully that's.
It is, but thanks for sharing your thoughts and advice, and I'm sure it's been kind of valuable to the students here. And yeah, thanks for taking the time out of your day to kind of speak to students here. I mean, I think you were only here for half an hour. We've just gone over half an hour. So any final words you want to share?
No, I just appreciate the opportunity to speak to the group today. Hopefully it was helpful. Hopefully that gave a little bit more insight into a couple paths you could take in the structural engineering buildings professions world. And yeah, if you have any follow-up questions, please, I think Akash or Professor Derricks could help connect you, and happy to answer any further questions you might have offline.
Absolutely. Thanks for the offer, Michael. And yeah, thanks again for taking the time out. And yeah, take care.
All right. Thanks, everyone. Have a great day. Bye.
Thanks, Michael. So fantastic. So we had Michael, a professional engineer, structural engineer, to kind of share his experience of what it's like to do his day job. Well, several day jobs, actually. So he has had a wide kind of range of jobs in his career so far. So hopefully that's kind of given you a taster of just what one person's kind of engineering path can look like. And so clearly there's a lot of kind of opportunity even within one person's path. So there's, a huge range of things that you can actually do within engineering.